Thank you so much for your time. We're so excited to share with you here at Flink Forward how we built a self-serve stream processing platform with Flink. I am Manuela Way. I'm a principal product manager with the Intuit data engineering team. Here with us also is Ping Zhou. She's a principal software engineer, and Nick Wang, senior development manager for the stream processing platform. Today, we'll be sharing with you an overview of the stream processing platform and its benefits, the platform architecture, then we'll deep dive into the tech stack, share a demo with you, as well as roadmap and lessons learned, and we'll have time at the end for questions. So to start out with, Intuit provides financial software such as TurboTax, Mint, and QuickBooks. Our customers are consumers, such as you and I, small business owners, and self-employed. But what's common with all of our customers is that we want more money in our pockets, we want more time for our lives and to grow our businesses, and we want more confidence that our finances are being handled properly. So how do we achieve that? Intuit's mission is powering prosperity around the world. And the Intuit data engineering team is very much in focus towards that goal by providing AI and data-driven platforms, such that our customers, for example, who are using QuickBooks Payroll, want the right information at the right time when they're dealing with a problem in the product. Or they want to be intelligently routed to the right expert who can help them quickly resolve their issue. Also, in TurboTax, customers, again, want to ensure their taxes are done correctly with high confidence. They want to save time, and they want more money in their pockets. So how do we achieve this? When we interviewed our customers, who are the product teams around Intuit, they said they want to focus on development of stream processing applications such that they can provide real-time personalized experiences for their users while in product. In order to achieve this, they spend a significant amount of time exploring the rich data sets at Intuit, understanding the schema and the lineage from where that data came from. And there's a bunch of operational concerns, such as how do they manage lifecycle, deployment, monitoring, that they ensure they have the right access control to data, and that data is properly securitized and in compliance. There's also all the infrastructure management that teams would have to handle. To that end, the goal of the stream processing platform is to provide a self-serve capability for developers to focus on development, while the platform handles all the operational and infrastructure management concerns on behalf of our users. So from day one, we provide self-serve capabilities which enable our users to create, deploy, and manage the lifecycle of their processors and their pipelines. Processors being the code, which is doing the transformations and aggregations, pipelines, which are an orchestration or a DAG of one or more processors. The platform handles the complexity of provisioning infrastructure such that it is multi-tenant, highly available, reliable, and scalable. We also manage the data security to ensure the sensitive data from our end users is properly securitized and that the right users or systems have access. We accelerate development of stream processing applications by providing an end-to-end dev and build environment with a Hello World starter kit to help our teams get started. We also provide flexibility with programming languages such as Python or Java and where their processors are running, for example, Flink. We also tie into the Intuit data ecosystem to give users access to the rich data and tools to explore the data, to understand the operational health of their system, debug issues, and manage costs. We provide out-of-the-box dashboards for operational metrics and cost in order for our users to be able to manage the performance and costs of their applications. Now I would like to share with you benefits of the stream processing platform. By providing self-serve capabilities for our users, they were able to focus on development of their business transformational logic, thereby reducing the cycle time for development from 3 months to within weeks. Second, when some of the capabilities were migrated from batch processing to the stream processing platform, teams were able to realize a 240x improvement in availability of real-time data. Lastly, we were also able to achieve a 5x reduction in costs for these stream processing applications for the storage, compute, and memory resources. And now Ping will share with you architecture of the stream processing platform.
This is a high-level, generalized stream process pipeline. Use case looks like data can be ingested from different places to Kafka or other messaging system. Then perform data transformation such as filtering, aggregation, enrichment, join, and then push to the sink. For example, the real-time monitoring use case, data can be published from an agent which collects CPU, memory, JVM, application stats, application latency, network I/O, network latency, etc. to Kafka. Then perform downsampling, aggregation, filtering, join, or ML model to push to different sink, such as TSDB, Elasticsearch, or Kafka for further data transformation. How to enable users to build stream process pipeline quickly. Self-serve stream processing platform is the platform to build, set up application stream processing end-to-end system automatically. Our goal is to enable users to focus on developing their business logic and controlling the development of life cycle of their processes through interacting with the stream processing presentation layer, which is UX layer here. Our platform takes care of the rest. Users only need to be concerned with the iceberg above the water. Stream processor presentation UX layer will invoke stream process service. Stream processing service interact with the big data ecosystem to ensure the data governance. Asset management is the central registration of assets to enable data consumers search and obtain a full picture of lineage, processing, and data freshness. RBAC for access control of asset. Data protection serves for encrypting key and secret storage. Security compliance to ensure data is properly secured and in compliance. Monitoring provides real-time metrics and logging, which enable end-to-end monitoring, alerting, and debugging capability. Stream processing service also interact with Argo for deploying the application stream processing pipeline. It supports multi-tenancy and cost tracking to provide visibility on cost for different organizations. This is the tech stack of stream processing ecosystem. Customer experience is the layer above the water. Application layer is where the user does their developing their stream processing application. processor CI/CD layer is standardized development process which user checking their code to Git repo, which triggers Jenkins job to build code and push to the artifact repo. UX layer is the user interface, where user controls creation, configuration, deploying, and managing lifecycle of their stream processing application. The UX layer is primary abstraction between user control and platform responsibility. The layer behind the scenes are control layer, connects stream processing platform with the big data ecosystem. Pipeline CI/CD layer handles the deployment of processor artifacts to manage the infrastructure. Runtime layer is key foundational layer to abstract the platform from processing runtimes and enables the platform to evolve with fast change processing industry. Infrastructure layer provides the right compute and memory resources for running stream process application. It supports multi-tenancy, fault tolerance, HA, and scalability.
Thanks, Bing. My name is Nick Huang, and I'm the engineering manager of the stream processing platform, and I'm going to be taking you through a deeper journey through our tech stack. We'll start with the application layer, which, as Ting mentioned, is built around Apache Beam and Apache Spark. With each of the layers here, I'm going to talk about a guiding principle we use to make all of our technology decisions in these layers. And for this one, it's really around developer flexibility. We want to afford our developers that onboard onto the stream processing platform flexibility in both the language and the framework that they think is best for themselves and also for their use case. So to that end, we've built a couple SDK libraries that are wrapped around Beam and Spark. And the reason why we picked to build around Beam and Spark is for a few reasons. First, we want to make sure that we support multiple runners and runtime execution engines for the code that is written in the application layer. And this is in particular why we've involved Beam in our tech stack. Beam is specifically built to be agnostic to the runtime technology, whether that's Samza or Flink or Spark, or whatever else may be invented in the big data space in the future. So we did want to be able to future-proof our applications a bit against evolution in the space. We also wanted both of the frameworks to support multiple languages, which both Beam and Spark do. So we've got SDKs that are built for both Java and Python. And also we want both frameworks to support executing their code in either a stream or batch context. Now we are the stream processing platform, so we're primarily interested in executing things in a streaming mode, but Beam and Spark both support batch modes. And that's important for us because we've got sister platforms that involve batch processing. And we really want our customers to be able to seamlessly reuse their business logic in a streaming or batch context, especially for things like backfill or replay capabilities that might be more appropriate for a batch mode of execution. And you may be asking why we don't just have our developers reference a Beam or Spark SDK, and why do we bother building our own SDK around them? And that's because there are a couple of bells and whistles that are really helpful for making life easier for our developers. And in particular, that involves handling data access policies, especially for our Kafka topics, and also having really good metrics instrumentation and collection out of the box. So lag metrics, for instance, are things that we've incorporated into our SDK, and our developers don't have to think about it. And they always get lag metrics for free as long as they use our SDK. That brings us to the processor CI/CD layer. And this is a good point in the talk to remind you that when we reference a processor, that's really just a synonym for a code artifact that represents some kind of data transformation. And these will be composed into what we call pipelines. And a pipeline is maybe what you would call a stream processing application. So a pipeline is a composition of one or more processors that do different levels of transformations and that you want to deploy as an application. So here for processor CI/CD, we're really talking about just building your code artifacts. And so therefore, this is the least interesting layer of the stack because it's so industry standard. It's really just built around GitHub repos, Jenkins, build jobs, and publishing artifacts to Artifactory. The one thing to note is that we just auto-provision all these things for our customers whenever they create a new processor on the stream processing platform. So we auto provision a GitHub repo with a starter template and hello world example and unit tests and a Jenkins file with all the good security and compliance checks that we require at Intuit. Build pipeline is provisioned for you, and those things are all automatically rigged up to an Artifactory repo for your releases. So that brings us to the user experience layer. The thing to note here is that this layer is the last layer that's above water in the tip of our iceberg. So this is really where the rubber meets the road for our customers, because besides the IDE that they're using to actually develop their stream processing application, the user experience is what they're going to be looking at the most. So we really want to invest in a lot of good design and feature-rich capabilities in this layer. So to that end, the guiding principle here is customer delight. We really want our customers to feel superpowered and for them to feel like managing a stream processing application is easy and to accomplish all of this through a UI. So what we've built around here are UI widgets to satisfy this feature-rich experience, and those are built in React using our Intuit design system, so that design elements look and feel very similar to what you would see in an Intuit product. And we have integrations with operational dashboards and troubleshooting tools such as Flink for log collection, App Dynamics for profiling, Wavefront for metrics visualization, and ClickView for cost tracking. So the core function here is really just to send calls to our control layer microservice to manage and configure processors and pipelines, to operate pipelines, to browse the history of processors and pipelines. So, who changed what when, who broke production when, and also to see real-time pipeline status. And you can see a screenshot of what this user experience looks like here, but we'll go into more depth in the demo later in the talk. Now we go below water to our control layer. The guiding principle here is around a resilient data model. And the reason why we highlight the data model here is because that's what the control layer is really all about. It manages the life cycle of all assets on the platform. And so therefore, it really lives and breathes by the data model that we define for our platform. Also, the control layer is the single point of contact for all other dependent microservices in the Intuit ecosystem that we rely on. So we want to make sure the data model is future-proofed against any changes in our ecosystem as well. So we really do a lot of thinking into designing the data model here. So what we have is a Spring microservice to service calls from the UX layer, and an Aurora DB metadata store that tracks all of this, all of the versions and changes in processors and pipelines on our platform. As mentioned, core functions really service the calls from the UX layer and also to integrate with our enterprise ecosystem. And these integrations with dependent microservices are not unlike what we would expect to hear from a lot of your companies as well. So these are things like registering assets to a particular user, doing role-based access control for users on what they can and can't do to these assets, authenticating with other microservices within the enterprise ecosystem, and perhaps most interestingly, also tracking data lineage. If you're not familiar with the concept of data lineage, this is really being able to establish and explore the relationships between data sets and services that transform data. And this is something that you get for free with the stream processing platform and what the control layer takes care of for you. So users don't have to register relationships. They can just rely on our platform to do that for them. And so therefore, we start getting a really rich data set in our lineage service of how Kafka topics are related to one another through stream processing pipelines, or even how data sinks and sources at rest, like databases, Elasticsearch instances, how those are related to stream processing pipelines. That brings us to the pipeline CI/CD layer. And the driving principle here is really around standardization. So this layer, as a reminder, is around the deployment of the stream processing applications onto the infrastructure layer. So what we want to accomplish here is to really mask away any complexity in terms of creating Docker images and deploying resources to Kubernetes away from our customers, and to do all this in a very standardized format. So to accomplish this, we have a Docker image build job that builds the image upon each deployment of a pipeline. We have a compute resource optimizer that takes input from the customers on what they think they need to provision for their pipeline, and then we determine the best EC2 nodes with which to satisfy that request. And then we use Argo workflows to deploy pipelines on top of this compute infrastructure in Kubernetes. If you haven't heard of Argo before, that's an open source technology that's sponsored by Intuit that makes lifecycle management and CI/CD on top of Kubernetes very straightforward. So I encourage you to look into that if you haven't already. So the core function in this layer, it's really around these first two bullet points, which is we never want customers to build their own images, and we never want customers to directly touch Kubernetes. And we want these things for a couple of reasons. First, it really simplifies the RBAC model of our platform. We don't have to give our customers access to Docker image repos, and we don't have to give them administrative access to compute infrastructure in Kubernetes. That's all abstracted away for them. This also means that we can really enforce security and compliance on these images and really guarantee that any image that gets deployed through our platform is a safe image, and we shouldn't feel nervous about it running on our cluster. It also accomplishes what we mentioned, which is standardization and uniformity and how resources are deployed and cleaned up in Kubernetes. So this really makes customer service and troubleshooting a lot easier because we don't have to wonder about anything funny happening in the CI/CD pipeline. We just really need to focus on the business logic that a customer has built. That brings us to the runtime layer. And there are many words that we could have used to focus on and guide us in our decisions here, but really it comes down to one word, and that's scalability. We really wanted to pick technologies that are industry proven and battle hardened in terms of the use cases at scale that they can support. And that's really why Flink is a first class citizen in this runtime layer. Flink is our stream processing engine of choice, and it's what we got all of our customers to use through the development of Beam applications at the application layer, and we execute those on top of Flink. Now, as I mentioned, we do support native Spark applications, so we do have Spark as well in the runtime layer. But for stream processing applications, again, we really encourage all of our customers to develop in Beam for running on top of Flink. So the components here are Flink and Spark clusters that get deployed through the pipeline CI/CD layer. For Flink, we also have RocksDB as our state backend. And for both Flink and Spark, we persist checkpoints and save points to S3. Now, the core functions here, we think the audience here is probably very familiar with these, but in no particular order. We wanted frameworks that support stateful processing. We want the runtime layer to have a lot of fault tolerance and resiliency and support at least once processing, which both frameworks do. We want low deploy and restart latency. So when customers want to patch their code or just redeploy things with a different configuration or perhaps upscale or downscale their pipeline, we want these things to happen pretty quickly. So we do optimize for patterns in these runtime layers that minimize that downtime for our customers. We want all of our frameworks to have rich operational metrics, so things like checkpointing, statistics, and stuff like that, so that our customers can really build very nice operational dashboards and Wavefront to really completely monitor the effectiveness and performance of their pipelines. We want our customers to be able to tune these runtime layers to their desire via our user experience layer, and you'll see a little bit of this in our demo later. Finally, we also want our runtime technologies here to support auto-scaling with load. Right now, that's a pretty manual process that our customers have to do. And so whenever there's peak periods in our calendar year, folks have to really scale manually and do capacity planning. But we want this to be more turnkey for our users, and we're looking to implement that soon on top of these runtime layers. That brings us to the final layer, which is the infrastructure layer. And really the most important guiding principle here is multi-tenancy. Because we are a self-serve platform, we have seen tremendous growth in our platform. And so we really want to have an infrastructure topology that supports a growing customer base at scale and also provides some good assurances to all the neighboring applications that are running together on the same infrastructure. So really the only component to talk about here is our Kubernetes cluster that runs on EC2 today, but we're going to soon be running that on EKS. The core function that I was alluding to was really namespace isolation. So especially for production applications, we want to give our customers assurances that they're not going to suffer from any noisy neighbors in production. For lower fidelity environments, we are relaxing that requirement and that you are more truly multi-tenant with other folks. But since those are less critical pipelines and lower fidelity dev environments, that is okay, and also provides you a little bit of cost savings for your pipeline because you're sharing those resources, those compute resources with other people. Just like the runtime layer, we want low deploy and restart latency for pods on Kubernetes. We want also rich operational metrics, in particular for the infrastructure layer, resource consumption metrics. And this is really to give our customers the ability to transparently see if they're resource constrained and if that's what's affecting their performance, or if they're over provisioned for resources and have a lot of cost savings on the table that they can take advantage of. Fault tolerance across availability zones is something that we want our infrastructure layer to support. And billing tags, which may seem like a not very interesting topic, but it's actually very important for our platform, since we are self-serve. We want folks to pay for the infrastructure that they use in an equitable manner. So we work a lot with other teams in Intuit to make sure that especially the network data transfer costs, which is a very significant cost of running a stream processing pipeline, gets fairly attributed back to the right business unit. So this is all taken care of on behalf of our customers in our infrastructure layer. And you can track your costs in the ClickView dashboard that we talked about before. Finally, we want the infrastructure layer to support a multi-cluster topology. And this is mostly because we've got use cases that ask for multi-region resiliency. And also, given the nature of the products that we have at Intuit, we have a lot of sensitive and classified data that needs special infrastructure to handle. So we've got data compliance standards that do require dedicated compute infrastructure for certain levels of classification. So we need to be able to spread our pipelines across multiple clusters. And that includes the tour through our tech stack. And so now we'll put it all together and give you a demonstration of what the stream processing platform looks like. Okay, here you see our Intuit developer portal. And this is a one-stop shop for all developers at Intuit to access all the self-serve platforms that we have created. So to access the stream processing platform in particular, a user would create data processors and data pipelines. I'm not going to go through the creation workflow because that takes a little bit, but instead I will show you some real world examples that our customers have. So here's an example. When you create a processor, this is what you're going to get. As mentioned in the processor CI/CD layer, we auto provision a GitHub repo, a Jenkins build job, and also homes and Artifactory for your release and snapshot artifacts related to your processor. Once you have this processor, you're going to be developing and writing code and cutting releases for that code. And whenever you cut a release, you're going to have the option to add a version here to make that usable within a pipeline. So here you can see that this customer has defined 4 revisions of their pipeline that span various minor and major releases of their processor that they have deemed usable for other pipelines. And it's worth noting here that we really do encourage different teams to reuse each other's pipelines. And so part of this is to allow for stable releases that you can have external people be using while you continue to iterate on your pipeline and develop new features. So that's pretty much the user experience for managing a processor. Now let's go to pipelines. When you first request a pipeline, you're going to see something like this. First, we provision what's called a QA environment for your pipeline. This is the lowest fidelity environment that we provision to our customers. And this is where we have all of our customers start. This is where you're going to do basically like sandbox testing and iterative smoke testing of the features that you're building and just making sure your code works. You're not going to be running it at scale. You're going to not require very strong SLAs for uptime. And you're also going to be okay with a lot of people playing on your same compute resources because you're not doing anything that's business critical at this point. So here we can see that this customer in particular is not running anything in this environment right now, but we can take a peek at what they have configured in the past to run in this environment. So here you can see that they are using the processor that we were just looking at, and they've tied it to this particular revision. You can see that they've asked for 3 replicas of that processor. And what that equates to is there will be a stateful set deployed on Kubernetes with 3 pods. So basically 3 task managers in the Flink cluster that will be executing this pipeline. Each of those replicas are going to have 4 cores and 4 gigs of RAM. Then we can dig a little deeper into the runtime configuration of this processor, and that's where things get particularly interesting. So here you can see that we give users the ability to specify what their data sources and sinks are, and we actually require this. So here we can see that the user is having a Kafka topic as the source and also another Kafka topic as the sink. And when we talked about data lineage tracking, this is what we meant. We force the users to specify what their sources and sinks are, and we capture this information within the user experience. And the control plane takes this information whenever a new pipeline is deployed and updates our lineage service. So we can take a quick peek at what that looks like here. So this is our lineage service. And what you see here is that I have searched for any relationships related to the input topic that this particular pipeline is using. And you can see that this is giving me a visual representation of how this topic feeds into this stream processor and is outputting to this topic. And that there is something that might be reading from this topic and depending on it. So you can see very quickly the power of this lineage tracking tool that lets us really explore the relationships across services and data within all of Intuit. But returning back to this runtime configuration, you can see that the user has some use case specific runtime configuration that they've decided to implement in this configuration. But you can also see how we faithfully pass on any Beam and Flink specific configurations. So for instance, if the user wanted to switch from at least once checkpointing to exactly once checkpointing, they can do that all within the user experience, and we will take care of that in the deployment on their behalf. So once you're finished developing in your QA environment, we would give you the option to click this nice promote button and promote your pipeline into a higher fidelity environment. So the next environment that you have is called the E2E environment. The intention here is that you're not running at scale, but you are doing end-to-end integration testing. You may want to be providing your downstream consumers some early version of the new features you're working on so that they can do integration testing on their own. So this is really meant to be slightly stronger SLAs in terms of uptime and infrastructure reliability than the QA environment, but not as good as prod. So once you're done with your integration testing here, then you would be able to promote into prod. And this is the final destination of your pipeline. You can see here the customer is running something, and they're definitely running at scale given the number of task managers that they have. And this is where it's useful to dive into a little bit of the troubleshooting and operational dashboards that we link you to here. So if you click on your namespace link, you'll be taken to a Wavefront dashboard that summarizes your resource consumption in your Kubernetes namespace. So you can see here that the users actually pretty well provisioned themselves in terms of RAM, but has way over provisioned themselves in terms of CPU. So here you can see this is a way for customers to easily say, I've got some cost optimization opportunities here on the table, and I could probably shave a few dollars off this pipeline per day. If you click on this Wavefront link, you'll be taken to our custom Wavefront dashboard that shows you all the Kafka IO and lag metrics that are critical to assessing whether your stream processing pipeline is keeping up with the input load. And again, this is what we build into our application layer through the SDK. So as long as the customer is using our SDK, they get all these metrics for free. And you can also see there's links to Splunk logs and a cost tracking dashboard. And you can also see this real-time status of how all the task managers and pods that are supporting your task managers, as well as your Flink job manager, how long those have been running, are they restarting frequently, are any of them in an error state? Luckily, this one is completely healthy, and that's what we like to see. And that is it for the demo.
Now we would like to share with you lessons learned from building the stream processing platform. By providing self-serve capabilities from day one, we enabled our users to accelerate their work of building stream processing applications. Meanwhile, the platform team was able to iteratively improve the capabilities that we provide for our users. Second, by treating processing pipelines as software, we were able to incorporate best practices such as CI/CD into development process. Third, by offering visibility into operational monitoring and costs, teams were able to iterate on improving the performance and cost of their pipelines. By failing fast and learning fast, we were able to work with teams to quickly iterate on providing the capabilities which are needed for stream processing use cases. We also learned some interesting uses of data pipelines by our users. For example, by A/B testing their processors or runtime configurations. And lastly, there were a lot of learnings around performance and cost trade-offs. Coming up next for the stream processing platform, we're working on improving deployment such that there's reducing the downtime for applications while there's an upgrade. Second, we're looking at using runtime metrics in order to auto-scale the processors to handle spikes in traffic or seasonality. We're also looking at using templatized pipelines to provide additional capabilities for teams to share their work and accelerate. And as more Intuit products are supported in multi-regions, the stream processing platform is also looking to be supported in US East to support real-time use cases. We're also looking to support large local state store for stateful processing. And lastly, additional language capabilities in Beam Python or SQL to support new use cases, as well as a new class of users, more like analysts who would be interested in transforming their business data. Thank you for taking your time with us. Our contact information is below if you'd like to reach out to us for more information, and we'll take your questions now. Thanks.